Lesson 7.4 for pre-algebra is titled Write an Equation. So this is kind of tricky. It stumps some kids because they can't get from the story problem to the equation. So just bear with me on this. You probably recognize Albert Einstein's famous formula E equals mc squared. Many scientists write and use equations and formulas every day. Banks use equations to calculate interest and loan information. Statisticians use equations to find sports and population statistics. And doctors use equations to calculate correct doses of medicine. So they use it all the time. So here is a problem. A moving van rents for $29.95 a day, plus 12 cents a mile. Mrs. Smith's bill for a 2-day rental was $70.46. How many miles did she drive? So, here is some key things that they want to help you with. It says understanding the problem. What is the goal of the problem? To figure out how many miles she drove. For how long did Mrs. Smith rent the van? So you got to remember that. 2 days. And they told us it was $29.95 a day. And what does the van cost without mileage? So that would be the $29.95 a day. And what is the mileage charge? 12 cents a mile. So what they do is they break it up. So you take the words and then I'm going to write it into an equation. So I have a 2-day rental. So that is where they get this, 2 days, and then times the price per day, 2 times $29.95, 2 times $29.95, hopefully that makes sense, $29.95 a day times 2, plus 12 cents a mile. Now the 12 cents a mile, we don't know how many miles she went, so that is our variable, and they put M or X. And then the total was $70.46. So now you can figure out the problem. So you would take your calculator, you do 2 times $29.95, which equals $59.90, plus 0.12x equals $70.46. I'm going to draw my line. I'm going to minus $59.90 from both sides. So I'm minusing off the cost of the car. Minus $59.90, and that equals $10.56, and then it's 12 cents a mile. So then I'm going to divide by 0.12, and that equals 88 miles. So she drove 88 miles. So when are you ever going to need this? Well, let's say you work at the car rental place or the van renting place, but you're in the corporate office, and the corporate people are the ones who have to do all of this math to figure out to put into the computer, and then it's the same for all of their stores. So someone out there actually has this job. They have to figure out the computer, put in the problem, and then there's another person who's just at the rental place plugging in the numbers. So, a baby weighed 3.2 kilograms at birth. She gained 0.17 kilograms per week. How old was she when she weighed 5.75 kilograms? So, start with what you know. The baby weighed 3.2 at birth. So that's what you're going to start with, 3.2. She gained, so that's plus, 0.17 kilograms per week. Do I know how many weeks? No, that's my variable. And how old was she when she weighed 5.75? So that's going to be the total. That's how much she must weigh right now. So I'm going to draw my line. I'm going to minus 3.2 from both sides. So then I get 0.17x equals 2.55, and then I'm going to divide by 0.17. 2.55 divided by 0.17 is 15 weeks. So the baby is 15 weeks old. All right, try this one Bob bought a cell phone for 25% off. The sale price was $64.50. Find the original price. So if he bought a cell phone for 75% off, so you have the cost, I want to find the original price. So the original price would be X, because that's what we don't know. Now, X times not 25% off, because that's what he got off. He's going to pay 75% of it, of the original price. So this is the kind of the trickiest part of this problem. If it's 25% off, that means he is going to pay 75% of the original price. And then this is the original price. And then that equals $64.50. So then I'm going to divide both sides by 0.75. Divide by 0.75. $64.50 divided by 0.75 is $86. Oops. So he paid $86 for the phone. All right, that's it for your notes.